My name is Obi-Wan Pez, and this is Simplex Pachinko. We are looking to do some math by request tonight. So if anybody has any particular things that they would like to talk about, let me know. Ooh, syntax. Nice to see you again. Laz, good luck on your 3-hour-long exam that's due in 2 hours. Thinking of thickness. Okay. It's a lovely, vague start to the question. Like it. Let's see. Go over the way you define it, and then what kind of problem I've been having? Sure, go for it. So, the thing that I have learned how to do, Laz, is go into my calendar thing and be like, alright, I need to get it started by, like, this point. Ideally, if they're giving you, like, 2 days to get it done, you want to set a calendar reminder, like, before you go to bed to at least read it. And then, pretty much no matter how long the exam actually is for, or quiz, whatever, I would recommend reading it the day it's assigned, because your brain starts working on stuff even if you're not actually consciously aware of it. And then, yeah, like somewhere around the halfway mark, I'll put another calendar reminder for something, and then, you know, a few days before it's due, another one. Whatever time period is necessary for it, because, like, that's one of the things, is that I will forget stuff. It's been much, much worse since COVID. So, yeah. I just obsessively set calendar reminders, and it seems to work out okay. Canvas to both personal and student, yep. Hooray! Alright, if we have a function which is continuous and differentiable, we want curve, such that from all points on F, we take its normal and travel L in or opposite that direction. Okay. So let's start drawing a diagram just to make sure I've got the right idea. So, some curve, doesn't really matter what it is, continuous differentiable. And then we say we've got a particular point. From all points, right? Right, take normal. And travel a given direction, or a given distance, L. We'll make that work for us here. Assume those are all the same. Okay, or in the opposite direction. Any rhyme or reason as to which? So if it's not a choice, right, you want to draw a vector in the direction of the normal of length L in both the positive and negative direction, I suppose. Could be the way to say it. It's way too hot to drink still. Right, in certain areas these are definitely going to overlap each other because we're doing all points. So if we get 2 points which are on an exceptionally curvy curve, then we end up with 2 normals which are going to overlap each other. Yep. And most of the rest of these are not exactly going to be sort of close. Okay. Area can be computed with int AB square root of 1 plus f prime squared dx. So that would be surface area, or arc length. Yeah. Multiplied by your L. Okay. Yep. So it's always going to be height L. And yeah, when it doesn't overlap. So I think you're also going to have a little bit of potential trouble in... Well, no, not really, because, again, continuous. So we're doing all points. Yeah, okay. No, I'm good. So if they were to overlap in a really significant way, like this, then I assume that you would want this to either be subtracted off, right, or just not counted at all. I think that that is going to be very tricky. Now that is a naive perspective because I have not actually looked at this. From a computer perspective, it'd be real easy. So you'd say, like, I want you to calculate the integral, provided that it doesn't end up, find the area out to L or an intersection of these two lines, or minimal intersection. So, you end up with something like this. We only want it to calculate, like, out to here, say. Right, wherever these points end up being, the intersection points that are closest to here. And when we're doing, this over an infinite number of points, it kind of falls out. It makes it obvious where you're doing this. Okay, yeah. So largest L where there are no overlaps. So that also is going to be, that is going to be a part for Zach to look at, because that's some real analysis stuff. If you should, in fact, be able to find a largest L by... I mean, we ended up calling it mean value, or not mean value, yeah. You can use... So I think if you can show that there is some largest L for, in fact, all functions, it doesn't matter, like, what function you have, there is always going to be some largest L when it has any sort of curve. If you have a completely flat line, you could go to infinity. But in that case, it's boring, so why would you do it? But I would recommend saying that there is, as long as it is a curve, there is going to be some largest L value for which this will work, and if you can find that largest L, then this is how we're going to proceed. And you could always just do the integral times L, whatever that is. At least I think so. And it's been a long time since I've really done any sort of work in real analysis or numerical stuff. Number theory. There we go. Oh. Oh, what went wrong? Holonami, how's it going? Simplices combinatorial, categorical, or topological? They are more combinatorial, I would say, probably, or at least the ones that I am that I did my half-ass research on and named my channel after. My problem is that I need to formalize a method by which Python or some other language will create an n-dimensional matrix, and I'm not particularly good, let's say, at like almost any programming language at this point. I think my strongest is probably MATLAB, and even that's, you know, simple stuff. At this point, I've fallen so far behind. Let's see. Yeah, I had for a while been working on trying to do some stuff with Lean Prover and Project Euler. I know Dawn Does Math really likes working on some of the Project Euler stuff. I haven't done it in a while, but let's give a shout out to Dawn there. Anybody who doesn't know Dawn Does Math, and is currently live. In Project Euler, you... right. Should probably sign in, I guess. Yeah, I have not gotten super far, at least in Python. For MATLAB, I think I went... I think I was on Project 40 or something like that, but... No, so my n-dimensional matrix is to try and just, like, input... I mean... So I need it to be of variable dimension, which means that at any moment I could just ask it to plug in, you know, fourth or fifth dimensional or whatever else I want to do, or just, you know, 2, because 2's fairly easy to work with, and that's the standard. So I had been doing the Pascal's triangle computations, so n choose r. And so I would like to pull all possible coefficients from the nth dimension kth row of whatever slice we're working with. So my actual channel name comes off of this picture, sort of, where my dean was trying to do some work researching with students at our community college on how to create a three-dimensional simplex, and then figure out the same patterns that exist in Pascal's triangle here over on the 3 simplex. You know, 2 simplex moving up to 3. So I was working in one direction where I was taking all of the horizontal cuts, which is what you see where it says n equals 3, and then moving to the right where it has 1, 3, 3, 1 around the outsides, and then 6 in the middle, 1, 4, 6, 4, 1 around the outsides, and 12s in the middle, etc., etc., etc. So all of that stuff moving through, I was trying to figure out, you know, slice by slice, what all of those values were going to be. And I generalized it. It was super easy because it's just n choose k1, k2, k3, k4, etc. However far you need it to go. Number of dimensions are the number of choices that you're given at each level. So, you know, when you're talking binomial theorem, n equals 2, you can either go left, right, left, that's your right, left or right, and it reaches a certain state toward the end. When you go up to n equals 3, now you have 3 choices, so you could go toward A or B or C. And so I did that on that picture. That particular picture, I did a really crappy version myself. It's actually, I think, on my profile. So I did a really crappy version of it, and a graphic designer friend of mine ended up making this. And I was like, dude, how much do I owe you? And he's like, please. I was like, no, really, I need to pay you for your work. He's like, come on. How long have we known each other? I'm like, ugh. He was like, if you want a real, actual good one, this is something I knocked together in like 30 minutes. If you want an actual piece of art, then I will point you in the right direction. I'm like, okay, fine. So yeah, I was hopeful that we do some... I mean... I'm hopeful that someday I can actually work on Project Euler in earnest, but for the moment I'm getting stuck on pretty easy stuff, so it's you know, I need to improve my coding even before I do some of this stuff. ND array from NumPy, okay. That might help. I also am running Ubuntu, so there's several things that they're like, why don't you use a different distro? And I'm like, but that involves like either partitioning or wiping out a whole bunch of stuff, and I don't want to do that. I'm starting to turn into grumpy old man, and it's, my kids would probably at this point say starting. Arch, yeah. But I pulled up NumPy, and it wasn't as easy as just like pulling something online. I probably could do it now because I'm at least somewhat well versed in using Ubuntu, and like might be edging ever so slightly closer to becoming a power user. We'll see if that happens before the fall off starts happening in my brain. But yeah, the I've been trying to get yeah, I think it's pip that it does actually work with, and then I have to redirect it in a bunch of different ways to make sure it gets to the right place. But yeah, maybe that's just my misunderstanding. The other thing that I was trying to do, I was trying to get DaVinci Resolve to work, and like I just can't get it to work, and like I'm trying to follow some guy's video on YouTube, and I'm just like, I just need this to work. It's so close to working, but I was asking a guy about this thing, and he was like, well, you should be able to fix it doing these series of steps, and I followed those series of steps, and it did not do it. So I still need to go back a couple more times and, you know, have a quick chat. But it also makes me ever so slightly sad, because if I had DaVinci Resolve working, a lot of my stuff would be on YouTube by now. So, like, I need to get on it. But, yeah, and that's the other thing, is my kids are also home for the rest of the week. So... yeah, that could be nice. Thank you. Oh, and we also did Lean. If anybody does not know Lean Prover, Lean itself has its own community, and you can do math, and there's all sorts of cool things that you can do with it. You can have your Ubuntu installation of Lean itself, or you could get used to Lean in the natural number game. This is something else that we've been doing for a while. I haven't actually finished it. We're getting kind of close, but... This is adam.math.hhu.de, so it is a Deutsche website. However, that should work. Yeah. If anybody is interested in learning Lean or trying to, okay. Learning Lean or trying to understand how Lean works, this is a very decent website for it. from the home here, we have our tutorial world, numbers 1 through 8, addition world 1 through 5, multiplication, and implication. From here, this goes to algorithm, advanced addition, and power world, and then to inequalities, and then to advanced math, advanced multiplication. So the structure of this is very much in the same vein as a linear algebra class, where you go all the way back to the beginning, and it's like, okay, here in tutorial world, we're going to learn some basics. So in this case, right, it's going to tell you about reflexive property. And using the reflexive tactic in Lean is going to say that the thing on the left-hand side is going to be equal to the thing on the right-hand side. If it is not literally equal, it will fail. So, you know, be careful. And when we do this, we do substitutions. So in terms of here, we have H is the statement y equals x plus 7. And down here we have 2 times y is equal to 2 times x plus 7. We want to replace y with x plus 7, which is statement H. So we say rewrite H. And when we do that, it then automatically plugs in, as we see at the bottom here, 2 times quantity x plus 7 is equal to 2 times quantity x plus 7. And then we say, hey, that's a reflexive property. You could, in fact, do all this on one line and say, like, I'm just going to do rewrite H, comma, reflexive. And then it'll execute those in order. If you're confident with what you're doing, it just pops in. And then we start talking about, like, what does successive mean? So there's some other really neat pathways to get through all of this stuff. Addition world, we start looking at induction. So using the induction tactic, how do we then go through any particular proof and say, like, you know, this symbolic logic proof is going to get us step by step through this whole process. We're going to say run an induction n with d and hd. So then it says our goal 0 plus n is equal to n is our ultimate goal. Induction n says that we're going to run an induction on the variable n. So what do we do with induction? Well, induction proofs say we're going to start with a base case, and then we're going to assume that it's going to work for any particular, in this case, d. Nope. It's going to work for any particular HD, so in this case 0 plus d is equal to d, and then we have to prove that the successive is also going to work for that. So when we go through this, we said, okay, this is the goal, 0 plus 0 equals 0. We just said rewrite the add 0 function, which says 0 plus 0 is just 0. So 0 plus 0 is reflexive. That's our base case. And then when we move here, we assume that we can use 0 plus d is equal to d, and then we have to show that 0 plus the successive of d is equal to the successive of d. So there's all sorts of cool stuff. Like I said, it gives you examples, it gives you the ways in which you can actually plug this stuff in. And we ended up making it through multiplication and implication. I have not seen Power, Advanced Addition, or Algorithm World at all this playthrough, so we'll see how it goes. But yeah, natural number game is very much here's the beginning of a linear here's the beginning of an abstract algebra class. Go. Yep, and there is a great community that works on actual, or like expanding actual mathematics out further. And the ultimate goal for some of the research groups is to give the language and some basic rules to an AI system and have it learn mathematics from scratch. And then, once it gets the basic rules down and has a structural framework on which it can work, then they're going to start saying, like, go prove some stuff, and then get back to us when you found some interesting statements. So the AI ultimately is, going to be designed in order to create new mathematics that does, in fact, play by the rules. It won't give you some weird hallucination like the large language models. If anybody does have any questions on mathematics, I am very willing to answer anything there. I can also just start on some math puzzles or various other things that I have laying around. Or we can pop on a Discord and find some math problems to work on. But whatever anybody feels like, we shall be here. And yesterday's... Okay. For anybody who doesn't know, my name is Obi-Wan Pez, and this is nSimplex Pachinko, and I also work on a differential equations class, which I am currently teaching on Monday, Wednesday nights at the same time as this stream is, any other time. So that's 9 p.m. BST, 2,000 hours, I guess, whatever it's called. UTC, which ends up being 1600 Eastern US and 1300 Western US, so Pacific. I am an American. I am currently living in Great Britain, in the UK, in Yorkshire County, so if anybody is curious about what that's like, I can also speak to some of it at least.